Alrighty, how's it going, everybody? So I'm going to be posting another set of notes. This is an extension of 6.2 only because the first part of 6.2 just has so much in it with the properties of rational exponents. Because now inside of 6.2 there's also the properties of radical expressions, okay? Now inside this right here, we need to go ahead and talk about the product property and the quotient property, okay? Now, you'll notice here in the product property, you have the nth root of a times b is equal to the nth root of a times the nth root of b. Now, what that's saying is you can basically take this section right here and you can split it into two separate ones, okay? And this can also be said for the quotient property where we have this guy right here. He can be broken up into the nth root of a on top and then the nth root of b on bottom. Now, of course, you just have to make sure that you do not have b. It won't go to 0 because otherwise you once again have a undefined fraction. Now, let's go ahead and take a look at some examples, though. So for the product property, say I had something like this. The cube root of 4 times the cube root of 2. The way you could rewrite that is all in the same root. You could say the cube root of 4 times 2, which would then be the cube root of 8, because 4 times 2 is 8, and then the cube root of 8 is just 2. Now, the quotient property, let's do an example of that one. Say you had the fourth root of, 162, divided by the fourth root of, let's just go with something easy, 2. The way you could rewrite this is the fourth root of 162 divided by 2. Okay, you could write them all in the same one, which then that makes that easy because then you do 162 divided by 2, which is the fourth root of 81. And then the fourth root of 81 is 3. Okay, and arguably plus or minus, right? Plus or minus 3. So that right there is the product property and the quotient property, okay, that you're going to be doing on your homework, okay? And let me see, is there anything else? Oh, yes, let's make sure we talk about writing radicals in the simplest form. Let me erase this right here so that way we can get to, so I can have more space. Perfect, okay, so when I say writing a radical in the simplest form, there's certain ideas and concepts that we have to understand that we can't have radicals inside the denominator of a fraction, okay? That's something that's just not allowed. And so let's go ahead and make sure we understand that. And also, too, there's something I've worked with you on before that if you notice that if you try to take the cube root of, and let me go ahead and just do it. Let's do the cube root of 135. I mean, if you try to do the cube root of 135, that's just not going to work. The calculator is going to give you a decimal. But we know how to simplify that. We could simplify using that factor tree, and that would break up into 27 and 5. Now, 27 could break up into 3 and 9, and then 3 and 3. Now, in order to leave this radical, we need 3 of a kind. So I can use these guys, these 3 3s. And so that means a 3 gets to leave, but what has to stay? This lone 5 does, okay? And so this right here would be the simplified version of that radical, 3 times the cube root of 5. Now let me talk about that other scenario where, say you have a radical in the bottom of a fraction, okay? The fifth root of 7 over the fifth root of 8. Now what we have to do to make sure that this fraction is good to go is we have to make the denominator a perfect fifth root, okay? And that goes for anything that you might be working with. So say you had a fourth root at the bottom, you try to make it a perfect fourth root. Or if there was a third root on the bottom, you try to make that number a perfect third root. Now, asking yourself, what can I multiply this 8 by to accomplish that goal? Well, I could multiply him by a fifth root, because remember, it has to be the same root. That goes back to the product property we just learned seconds ago. It has to be the fifth root of 4. Now, you're going to be able to see my train of thought in just a second, but remember, what you do on bottom, you got to do on top. So I got to multiply this by the fifth root of 4, okay? So in turn, this ends up being the fifth root of 8 times 4, and then you have the fifth root of 7 times 4 on top. Now, that's going to simplify to the fifth root of 28, and then the fifth root of 32. Now, what's really cool about this is you can go ahead and proceed with doing the fifth root of 32. The fifth root of 32 is actually 2, believe it or not. And the fifth root of 28, we cannot do that. I could try to see if we could break it apart, and it's actually just into the 7 for it. There's nothing that we can do, so we just fifth root of 28. Okay, and that right there is a simplified radical. So that way, we just can't have anything in the denominator. No radicals there, okay? Now I'm going to show you something that might hurt your noggin a little bit, but bear with me, okay? I'll send more videos if need be. But we need to make sure we're okay with this. If I were to say something like this, because after I show you this, it'll expand upon a harder problem. But if I were to give you 16, would you guys agree that that's equal to 4 squared? Right? Do you see how I took now this whole number right here, this 16, and I now converted it into a number with an exponent? Okay? So that's something that I need you to be okay with. Kind of like saying 25 is equal to 5 squared. Okay? So keep in mind, that's kind of what we're going to. Okay? Let me try to think of a possible... So let me say about, like, let's do 216. That's equal to, I believe, 6 cubed. And let me double check my math. 6 times 6, and then 36 times another 6 is 216, right? So that is correct. So this right here transformed from a whole number to a number with an exponent, okay? So keep that in mind when I'm doing this next problem, and it will make more sense in terms of all the madness, okay? Now, I'm also going to be utilizing some ideas and thoughts from that first video, so be ready for that, okay? So let me give you the fun one, okay? So say I gave you the cube root of 3, and then the cube root of 18, and let's do the sixth root of 2, and then the sixth root of 2. So the first thing we're going to utilize is what we just learned from the initial part of the video, the product property. And that's when we can do the cube root of 3 times 18, and then we can do the sixth root of 2 times 2, because they have the same root, right? So 3 times 18, that's 54. Yep. And then the sixth root of 2 times 2, got it, it's 4. Now, what we need to do now is make sure we get that radical out of the denominator. Now, in order to do that, we have to make that denominator a perfect sixth root. Now, in order to do that, the way I like to think about it is 4, what can you break 4 up into? 2 times 2, right? Well, in order for us to be able to leave, we need 4 more of these, right? We need 2, 2, 2, 2. These are the 4 that we're missing right here, okay? We don't have these 4, right? So let's go ahead and multiply that to the denominator. Now, what is 2 times 2 times 2 times 2? Well, this whole section right here, if you multiply that all together, that's 16, okay? So what I need to go ahead and do, and I'll rewrite it, we have the cube root of 54, and then the sixth root of 4. I got to multiply it by the sixth root of 16, right? Because this is the 16 that I needed, and I got to make sure it's in the sixth root. Now, what I do to the bottom, I got to do to the top, so then I have the sixth root of 16. Now, this is going to give you the sixth root of 32. And then you have the cube root of 54, and then times the sixth root of 16. Now, please do not multiply those together. They are not the same root, okay? But the sixth root of 32, that is, I believe that's 2, right? That's what we wanted. That's 2. Now, on top, remember that thing I showed you just a second ago that said make your brain hurt a little bit? What I'm going to do is I'm going to rewrite those roots on top as exponents like we did yesterday. The cube root of 54 can be seen as the 54 to the 1/3 power, correct? Now, the 16, the 6th root of 16 can be rewritten as 16 to the 1/6 power, okay? Now, let me move some stuff out of my way, or move everything up. Now, looking at this right here, I cannot multiply the numerators together because, first and foremost, the base of it is not the same, and the radicals were not the same, okay? So I could change that, though. I could easily fix that because I can convert 16, remember, into 4 squared, right? So I have 54 to the 1/3 power times 4 squared to the 1/6 power, okay? And then all over 2. Now remember from our things we learned yesterday, we said that this right here, I could go ahead and multiply, right? Because I raised a power to a power, so that power property. I have the 4 times 2 times 1/6. Now some of you might be able to see where this is going. What's 2 times 1/6? Watch this, it's 1/3. So now I have 54 to the 1/3 power times 4 to the 1/3 power. Now, converting those back into radicals, I just wanted you to see it all. I now have this. And now I have the ability to go ahead and do the cube root of 54 times 4 divided by 2. Now, 54 times 4, that's 216. Cube root of 216 divided by 2, and that gives you 6, like we said previously. And then what's 6 divided by 2? That's 3. So, yes, you might encounter one of these, okay? So please be ready to go ahead and utilize thoughts and concepts from yesterday, okay? Or not from yesterday, but from the last video, okay? So please be understanding that there's not a one size that fits all for these. If you're trying to figure out, like, is there an exact way to handle and solve these? Truthfully, you just have to play with the numbers and be willing to utilize different methods to come to an answer to fully simplify. Now, if you run into an issue or if you're struggling, make sure you let me know. I'll make sure you won't be stuck there forever. Just send me a quick email and I'll get you another video, okay? Or maybe or send me your work. Also email me your work so that way I can see where you're at. Now, what we're going to talk about next is another type of multiplying, okay? Or simplifying a radical, so let's also go ahead and do that. Now, this one is a little bit easier. Here, let me just hit that button real quick. There we go. Now let's try to look at this. So sometimes you might have a fraction or something that has not only a number but a radical mixed with it, okay? In order to go ahead and get rid of the denominator or the radical that's in the denominator, you have to multiply by its conjugate. Now what that means is you're going to multiply by 5, and instead of saying plus, you're going to do minus. Okay? And then, of course, what you do on top, you have to do, on bottom, you have to do on top. Now, looking at this right here, you'll notice for the denominator, this right here, that's the difference of squares. I don't know if anybody can see that, but that would be the difference of squares where we can go ahead and convert this into the a squared minus the b squared. So that would be our radical 3 squared. Now, you might be wondering, Mr. Farmer, do I do that every time? And the answer is yes. Yes, you do. Now, I'll show you another example so that reinforces that idea. But on the numerator, you have to just multiply what's up there. Well, 1 times what's on top, that's just 5 minus the square root of 3, right? Doesn't really change or affect anything. But on bottom, we got some more going on. 5 squared, that's going to be, let me get that. Then we got 25. Now, if you're squaring a square root, that negates it, right? That simplifies it. And so then you have 25 minus 3. So then 25 minus 3, that's going to give us a 22. and you have 5 minus the square root of 3, and that's your answer, because we can't do anything further. There's no more simplifying needed. So there's that example. Let's take a look at another example. Say we had something that looked like this: 9 over the square root of 3 plus the square root of 7. Now, you might be also asking, Mr. Farmer, are you going to give me something any crazier than a square root for like conjugates when I have to multiply by a conjugate? And the answer is no. I'm only going to stick with square roots. Anything bigger than that would be a little messed up. So let me multiply by the conjugate for the denominator. That's going to be the cube root, or not cube root, the square root of 3 minus the square root of 7. And then whatever I do on bottom, I got to do on top. So the square root of 3 minus the square root of 7, okay? Now remember, on the denominator, that's the difference of squares. So that's the square root of 3 squared minus the square root of 7 squared. And then, of course, 9 times the square root of 3 minus the square root of 7, okay? Now, on the bottom part, okay, that gives us a 3 minus a 7. And then for the numerator, you have to distribute that 9. So then you have 9 square root of 3 minus 9 square root of 7, okay? Now, 3 minus 7, that's going to give us 4, negative 4. So I have a negative 9 square root of 3 minus a 9 square root of 7, and then a 4 on the bottom, okay? And I guess more specifically, I'll make sure I'll put that negative down here. Boom. And then, yeah, that's your answer. Nothing more, because we can't do anything to the top. We have to just stick with this right here, okay? Now let's go ahead and take a look at the last part, adding and subtracting radicals. Okay, so for this one, adding and subtracting, say you had something as simple as the 4th root of 10 plus the 7 4th root of 10. What you're going to do is you're going to add the number that's in the front of the radical together. You're not going to add the radicals together, just the coefficient in the front. So over here, there's a 1 here. It's just not explicitly written. So this right here would give us a 8 4th root of 10. Now, that wasn't so bad, right? Now, you could also rewrite them and have them look kind of funky. You could have 2 and then 8 to the 1/5 plus 10, 8 to the 1/5. Now, looking at this right here, you should be okay with saying 2 5th root of 8 plus 10 5th root of 8. Now, in truth, some of you might be going, Mr. Farmer, do I have to do this step right here? No. If you're comfortable with seeing it the first time and saying, oh, well, that's 12 8 to the 1/5 power, I mean, that's fine with me. Also, you could rewrite it like down here, and it'd be 12 5th root of 8. These mean the same exact thing, ladies and gentlemen, okay? Now, subtraction's handled the same exact way. So say you had the, and here, let me give you one that's a little bit more difficult here. Let me clear this. There we go. Let's try this one. So say we had the cube root of 54 minus the cube root of 2. Now, I don't know if you remember, I mean, hopefully you do, it's written in front of you, but you remember that last problem we did with multiplying by the conjugate, and the answer was like the 9 times the square root of 3 minus, I think it was like 9 square root of 7. We couldn't subtract those because if you look at them, when you're subtracting, these have to be the same, okay? That was kind of, and maybe writing that property might be worth doing. So say you have a nth root a plus, and then I guess I'll put like a c over here, plus d nth root of a. That's going to be c plus d nth root of a. And the same thing goes, why did I put an 8? Bless my heart. A. that's what the overall formula is, okay? So if you're trying to add expressions together, you have to make sure that the radical is the same radical, okay? So here, we can't subtract because I've got a 54 and I've got a 2, but we could change that. So let's see how we could actually change this 54 to possibly being something that we could make into a 2. So looking at 54, let's try to divide him by something. 54 divided by, let's say, a 2. Start there. And that's going to give us 3, 9, 3, 3. Well, these 3's right here, wouldn't you say, wouldn't they be able to leave? They would, right? Because you need 3 in order to leave. So that gives me a 3 cube root of, now look at this. This lone 2, it's got to go back inside here. So we've got minus a cube root of 2. And would you look at that? These a values are now the exact same. So now we can go ahead and subtract. So what's 3 minus 1, right? 3 minus 1, that's going to be 2 cube root of 2. That's kind of a cute answer. There you go. So you might need to be on the lookout for moments like that, okay? Be on the lookout for those. In fact, let's do another one. Alrighty, so looking at this one, let's do the cube root of 5 plus the cube root of 40. Now, this right here, of course, you can't add these together because the number, the a value inside the radical, you can't, they're not the same, right? But I can convert 40 because I bet it goes 5 into 8, right? And this is 2 and 4, and then 2 and 2. Boom, there you go. So now you have the cube root of 5 plus 2 cube root of 5, because this lone 5 has to go back in. You know, there's a 1 here, right? So then 1 plus 2, that's 3 cube root of 5. So it's really not all that bad. You just got to break down the numbers, see what you need, and see what can come out of the radical, and then you're good. Now, as far as notes, that's it. Let me know if you need anything. Tell me if you're running into problems on the homework. I'm here to help. Please email me if you need me. Alrighty, guys. That's it for now.